In this video, we're going to look at how you can use asynchronous generators to stream data. I think that asynchronous generators is one of the coolest things to land in JavaScript, and I think it has huge implications for how we do programming. But it's also a lot of moving parts. So I want us to think back on like the series of episodes that led us here. If you want to watch from the start, there's a link in the episode description. In the first episode, we just looked at the concept of an iterator. We talked about how we can iterate anything with things such as the for of loop because they provide an iterator. An array provides an iterator, and the arguments object provides an iterator, and we can also create our own custom objects that provide an iterator so that anything can iterate over it. In the episode after that, we looked at generators, which is a way for us to create these iterators in a more syntactically sugary, more terse way. So generators themselves are not like some special magical concept. In the end, they just produce an iterator. So we don't need generators to produce iterators. We can also do them by hand if we want to. Then in the episode after that, we talked about asynchronous iterators. An asynchronous iterator is just like a normal iterator, it's just that it deals with promises. So it can go and, like every time you call next, it can fetch a new item over the network. But what I failed to do in the last episode is to clearly explain why and when you would want to use an asynchronous iterator. Because I had been selling the concept of an iterator earlier as, you know, a way to make a custom thing that you can iterate over. But in the async iterators example, I used a fake database that just fetched a couple of rows. And a lot of people asked in the comment, well, an array is already iterable. It already works in the for of loop. Why can't I just do promise.all on these database rows and then just return a promise of that resolves to an array and then iterate over that? What's the point of using an async iterable? I am so glad this question was asked. I really like when people are questioning new technologies and asking like, why does this exist? Why do we have this? What is the purpose of this? And just not using things mindlessly. Therefore, in this video, we're going to use an example where an array would be a completely impossible data structure to use. So an array, that's kind of like a box or like a long, you can imagine it like a set of boxes that are glued together of limited length. In some languages, it's limited length. In some languages, you can like just glue new boxes on top of them. But it is like a set of boxes, and then you put things in the array inside of these little boxes, and they are there. The limitation of the array is that you either get all or nothing. If you have an API of some database or like some file reader or something, and you just call read file and that somehow gives you an array, that means that all of the rows have to be read. You get poof, everything at once, which might be fine. That's a very simple way of reasoning about like a file. I just read the rows, I get the rows. I read the users table, I get all the users. I now have the users, I can iterate over them. Great. I mean, that's amazing. That's simple. Why not always use an array? Imagine that the array is really big. What do you mean big? Do you mean like 100,000 rows? Because that's nothing to an array. Like that is transferred really fast, even over a mobile connection, and like even a cell phone can handle 100,000 rows in an array really easily. Like computers are really powerful, even the small ones. Yeah, that's true. Computers are super fast and they are just getting faster and faster all the time. But one thing that grows even faster than the speed and performance of computers is the sets of data that we have to handle. So I want you to think for this when thinking about async generators, I need you to think beyond like small data sets, like 100,000 rows, because that's not big. I want you to think 30 gigabytes. I want you to think 100 gigabytes, things that cannot fit in memory. You can't read it all at once, even in the foreseeable future. And even when we get to computers that have 100 gigabytes of RAM, then we're gonna have data sets that are just several terabytes of data, and even like a data set might even be largely infinite. And in this case, I'm going to use the thing that I can, the data set that I can think of that is closest to infinity, and that is all the cat pictures in the world. All the kittens. And this is where the concept of a stream comes in. It's something that we ask for like a very small part of the data. We ask for the start of we ask for the start of a rope, and then we just start pulling the rope. We don't ask for the entire rope at once. So the interesting part about the concept of an iterator, which again, remember that it's just an object that we can ask for the next item constantly, is that it can express an array. Because an array is just, it works in that interface. It's while we have everything in memory, it works to just apply the interface of asking for the next thing, for the next thing, for the next thing. But an iterator can also be used to express a stream. We just constantly ask for the next thing, but under the hood, it doesn't really have all the things yet. It just asks for things as you go. And that's the power of a stream. And we can use an iterator to express that. Or express that is perhaps a wrong way of me putting it. A stream can conform to the iterator protocol. So async iterators is basically a way for us to express streams, and the purpose of streams is so that we can deal with things as they come along. So it might be really huge data sets, or just data sets that are like a couple of megabytes, but you want to show them gradually in the interface so that the user doesn't have to wait. Let's have a look at some code. All right, so this is observable HQ. It's kind of like a JavaScript playground. It's pretty darn cool. I use it a lot for prototyping. What you see here is a stream of all the cats on Flickr, which is a photo service that was huge back in the day, but then Yahoo bought it and destroyed it. But it's still around, and it has a really nice API for demoing stuff like this. You see here that we have, it's just a for await loop that we looked at in the last episode. And it, for every URL of cats, it just yields HTML, which is this, it's just an image tag, really. And then we see here that every time we yield this, then observable displays it. Think of this thing as just a, this block here as it's basically an async generator. It's both an async function and a generator. So it has the capability of both awaiting and yielding. It's a super, super powerful entity, really. But don't spend too much time understanding this line. That's not terribly important for this video. Like, we could just have, this could just have been like, you know, like render, whatever. Like, that's not the purpose of this video. The interesting thing is, what the hell is this cat? Where is it coming from? I'm going to show you what cats look like, but I want to stress here that I'm showing you nothing new. Like in the async iterators example, we saw exactly all of the moving parts that we're going to see here, but the example is going to look a bit more intimidating because it's using a real API service, and there's slightly more moving parts and complications related to that. but it's basically just the fetch API and the async generators that you're going to see. So looking at cats here, it's just creates these, it calls Flickr tag search cats, or like it calls Flickr tag search with the string cats. All right, fine. We're collapsing that, and we'll look at what Flickr tag search looks like. I need to reduce the font size slightly. There. We open this up, and we see here that it's a big function. Let's have a look at this thing first. Flickr tag search. This has nothing to do with iterators. This is just a function that returns. It returns a promise that resolves to an array of URLs to images that represents a page result of a tag search on Flickr. Wow, that's a mouthful. This is just calling the Flickr API for a search. We give it a tag, but we also give it a page because basically this result set of cats, that's just millions and millions of cats, probably billions. So we can't get it all at the same time. We have to give it a page, and every page is 100 cats. So you see here, we just call fetch with, you know, some URL here that is defined in the Flickr API. And then we parse the JSON. We know that the JSON looks like this. It has this weird structure. Photo is an array. And then for every photo, we extract we construct an image URL. This is how like the CDN URIs on Flickr are constructed. So what this gives us is a small chunk of the enormous search result that is all the cats on the interweb. Or, well, on Flickr, that's as close as we're gonna get. Let's scroll down a little bit to get to the meat of the iterator itself, or the iterable that is cats. We see here that the function that is Flickr tag search and that takes a tag, it returns an object which has just one method that is called symbol.asyncIterator. So this is pretty funky. It's a method that uses this symbol as its name. A less catchy but more accurate name for this would be asyncIterator factory or asyncIterator maker, because like this is that creates an asyncIterator. So again, this is what the for/of loop will call under the hood. It will, when it starts looping, it's going to call this function to get the iterator. And see what's happening here. See that it sets up a couple of variables here to keep track of the page index and photo index, because it's going to be iterating these things. And also sets up a cache because it doesn't. This iterator it's not going to get one picture at a time, because that would be very wasteful, because the way the web works is that there's a latency for every request. So we want to be batching the requests a little. Like, so 100 pictures, that seems kind of reasonable to just get 100 at a time, even though we can't get all in the world at a time. But getting one at a time, that would be a little bit too little. But the iterator, we want to expose that as one item at a time. So we're going to create a cache under the hood and have as a buffer. And that's what the cache is for. And we have this little fill cache function, fill cache helper here, that just does the Flickr tag search for whatever tag we provided, and then it's going to take the photos here and just stuff it into the cache variable. So that's the iterator setup. Then it returns the iterator here, and the iterator it has a next function. That's where the magic happens. And the next function is going to increment the photo index. It's going to be -1 from the start, but then it's going to like nudge it up 1 so that we're on 0. And then it's going to see if there's a cache, and if there is a cache, if that exists in the cache. In this case, it's not going to be that, so it goes down here. Then it resets the photo index to 0, and then it increments the page index. In this case, the page index is 0, and that means that we're going to end up on page 1, which is the first page in the Flickr search results. It starts from 1, not 0. It calls fill cache with the page index, and then it does a delay here for 2 seconds. I'm doing it like this delay exists for demonstration purposes in this case, because otherwise it would just blaze through these images in a very annoying manner. The delay function is just a function that it's basically a wrapper for set timeout that just makes it promise based. Just returns a promise that resolves after seconds. So this delay here, that's just a promise that resolves after 2 seconds. After that has resolved, we return an iteration object. We're not done, because frankly, we're never gonna be done iterating kittens. This is largely an infinite result set. And then the value is going to be the cache at the photo index. So the cache is basically the current page that we have loaded. So that gets us our first cat. It loads the first page and it gives us the first cat. When we call next, or for the for of loop calls next the next time, it's going to hit this line and it's going to see that there is a cache. It's going to see that there's also a cat at the photo index, which is not 0 but 1. It's the second cat in the photo index result. So it's going to just do this artificial delay, and then it's going to return that cached cat. Because again, remember that the first 100 cats are cached. And then it just loops through this for 100 cats. And then it's going to hit this line. It's going to see that there's cache. It's going to see that, hey, we're now out of cats in the cache. We're going to need to increment and go to the next page and cache that one. So then it goes down here. Resets the photo index because we're now back on the start, and then it increments the page, and then it fills the cache with that page, and then we're back iterating the next page, and then it just continues like that. Again, none of this is new. You saw all of this in the previous video. The difference is that this uses a real API instead of like a fake API that I created to illustrate a point. These are more moving parts, and it's just a more intricate example for that reason. But there's no actual new concepts. And that's it. That's the entirety of our example. And it all results in this constant stream of cats. In this example, we've crafted an iterator by hand. But we can also use generators to create iterators. And we have looked at that. We have looked at how to create synchronous iterators using synchronous generators. But today we're going to refactor this manually handcrafted async iterator, and we're going to create that using an async generator. And it's going to blow your mind how much sleeker this becomes. So let me expand Flickr tag search here, and I'm going to rewrite this bugger as a generator instead. So I'm going to comment this out, and I'm going to grab this, flip, and we do a function. I'm going to do just a normal function to start with. To start with, we'll begin with a function, and we're going to call Flickr tag search. And we want to grab this tag here. It's going to be cats. And the second argument to Flickr tag search is a page. So we just call it page index. This variable doesn't exist yet. Let's create that actually. Let page index be 1. This is asynchronous. It returns it sends a promise, as we can see here. So we wanna await that. Await. And in order to use the await keyword, we need to make this function async. Why? Oh my god, I'm jumping around. Sorry about that. Now, once we have this array, we want to iterate over it. So let's do that. For const earl of this result set that we await, we're gonna do stuff. Let's actually just break this out because it might be confusing to we're gonna just call this array. Like this will give us an array. So since we're awaiting here, this will be the actual array of the page. Or perhaps page data. That's a good name. So once we have some page data and we're iterating over it, we want to yield. There. This is again. Remember how this is how a generator works? Like this is how we yield the next item, or when we're asked for something like, oh, I want the next item, then we yield it upwards, and then we pause the generator because the generator is sort of pausable function, and then we won't continue, like the generator won't continue until the external world, the external consumer calls next on us. After we're done with this loop, once we've yielded everything on the in the page data, once we're out of data in the page, we just go page index. We just increment that. And I do page index +1, and then this generator is going to end, and we don't want that. We want it to just continue. So I'm going to wrap this in a while true. Like we tend to see in these generators, it's pretty much the vanilla pattern for generators. And yeah, that's the way it looks like. So now it's just gonna continue. And yeah, it's just gonna continue. There's actually no end condition here. Like hypothetically, we could run out of pages, but that's not gonna happen in this application's case. Like cats infinite. And I've now actually written the entire bloody thing. Have a look at this. Yes, do you see how little code this is compared to this? I need to reduce the font size to show these side by side. So this is the same as this. We haven't added the delay here, but that's the only difference. It's just amazing how much code we can get rid of by just having the possibility of the generator. It's pretty darn cool. Let's actually make sure that it works. Let me run this. Oh my god, boom. The keyword yield is reserved. Oh, of course. Sorry about that. We can't use yield because this function here is not a generator yet. We need to make it a generator, otherwise we're not allowed to use yield. So, womp, now it's a generator. Let's run that again. And now you see here that, oh, there's a lot of cats, and it's kind of jumpy and stuff. It becomes really confusing, and that is because we haven't added the artificial little delay that was on the last, on like here, these. So I'm gonna add that. I'm going to add it here. Let me actually increase the font size again so that mobile users can actually see something. Going to await a delay of 2. I'm gonna run it again. And now you see here that, now it's loading the cats in like this nice sequential manner. I'm gonna scroll down and just gaze upon how extremely sleek this is. This is just so cool. And that's it. I hope I've linked this notebook in the description so that you can fork it and play around with it yourself. It's very important to actually use these things in order to understand them. You can't just watch me do it. It's just too many moving parts and things. You just have to experiment with them on your own in order to fully grasp them. That said, don't get stuck on your own. Confusion is to be expected, and your fellow programmers are helpful. If you have a question, post it in the comments down below. Or if you want to support the show a little bit and become a patron, you get access to the Fun forum, which is also an amazing place to ask for help. Like, I hang around there a lot, and the people around there are so friendly and so nice and really good at explaining things. So make sure you use that if you are a patron. There are so many cool implications with async generators. We're going to be exploring them in future episodes, because if you haven't made the connection yourself yet, you might notice that this is now streams built into JavaScript. We now have this awesome syntax to express streams in a standard manner. So this effectively does, for async iterators and the async generators, effectively does what the native promises did. Like, we had these, prior to the native promises built into JavaScript, we had libraries like Q and Bluebird, but now we have this standard way of doing streams, which means that we can have libraries that operate on those streams, and we can mix and match, which is just amazing. We don't have to use these monolithic stream libraries like Highland or Bacon or RX. We can just use the built-in things and then just pick little libraries that does transforms and just use build our own functions, and then those things will be useful for all projects because they all deal with async iterables, which is amazing. So I think that depending on what questions people have, we might do higher order async iterables next time, like functions that create other iterables from iterables, like map for iterables, or we can filter the cats or something. I don't know. You have just watched an episode of Fun Function. I normally try to make these a little bit shorter than this one, but we needed to spend a lot of time on why and also show a real world example, and both of those take time. I produce this show every Monday morning, 0800 GMT. So tune in next week, but you will forget that, so you can click subscribe so that you don't miss it. Or if you're feeling frisky, you can just watch another episode right now. I am MPJ. Until next Monday morning, stay curious.